And I did tell you that on homework 16 that you can cross off number 3.
Oh, I was really trying to do that.
Yeah. See, because you be having that, you don't hear me, you know.
I don't have any music playing.
Today.
No, but I never play music.
So you're just halfway listening.
Basically.
Gotcha. I got you. Okay, so yeah. Homework 16, cut number 3. Because number 3 requires a quadratic formula, and that's a lot. So we're not doing that. Everything else is just factorable like we did in our notes. So it should be pretty straightforward. Okay, so in your note packet, go to page 1. Now we're going to go back to the first page that we skipped. One of your test questions, which is on next Friday, asks you to determine if it is a scalar or a vector. The difference between a scalar quantity and a vector quantity is that scalars have only magnitude. Where a vector has magnitude and direction. I was going to show that clip from Despicable Me. I know. That's the difference between the two. So we're going to look at these 7 questions, 7 statements, and determine if it's a scalar or a vector. All right, so let's get started. Riding a bike 1 mile per minute. What would you say that would be? Scalar. Scalar because we don't know the direction that we're riding. Riding a bike 1 mile per minute due east. Now that becomes a vector. A 20-pound child hanging on the monkey bars. Scalar. Who says scalar? Who says vector? I think it's a vector. Why do you?
It's like your gravity.
Gravity, right? Yeah. If you're hanging, right, you can only go. If hanging, that means we have a force, and we're hanging down because of gravity. So that's a vector. Wind blowing at a speed of 3 miles per hour. Scalar. Because wind can blow east or west, so we don't know what direction. Students running down the hallway. Scalar. Driving 65 miles per hour on a highway toward Chicago. Who says vector? Who says scalar? Why do you say scalar?
You can go to Chicago from Indy.
You can go from Chicago from different directions. We don't know we're going from Indy to Chicago. We didn't say we were going north, right? So it's a scalar. Wind blowing east at a speed of 1 mile per hour. That would be a vector. Okay. So keyword vector, you have to know direction. So now we got some notes. So at the very top of page 2, above where it says vector, because I probably should have given you a little bit more space. So in that little bitty slither of a space above where it says vector, I'm going to tell you the first 2 formulas that you will need to know for the test next week that will not be provided. So I'm going to white this out to give myself some more space. So the first one would be, how do you find, what's the formula for magnitude? Magnitude is the distance formula, which if you remember, which I don't know if you remember, but from geometry, is delta x squared plus delta y squared. Delta means change. So to find your delta x, I'm going to go ahead and write that. Delta x is x2 minus x1, and delta y is y2 minus y1.
Direction is the blue one?
What'd you say?
You said direction is the blue one?
I can't hear you.
Direction is the blue one?
No.
Wait, what is the blue one?
That's how you find delta x and delta y. Direction is an angle. Angle. Who remembers, and you always use tangent. Who remembers if tangent is y over x or x over y? Which one is tangent? So we're going to use delta y over delta x to find our direction. Now, let's go ahead and do that with this vector here. We have our initial point, and this is what we call the terminal point. For your initial point, we're going to label that. We always label that as point 1, and our terminal point is point 2. So let's go ahead and find our change in x and change in y. To find the change in x, you're going to take x2 minus x1, which would be 7 minus 1, or 6. And to find your change in y, you're going to take 6 minus 4, and you get 2. So we call this delta x is the horizontal component, and delta y is the vertical component. Okay, so on the test, it'll say, write it in component form. So when we write it in component form, we always put our change in x first and our change in y second. So let's talk about those brackets that I just made. Those are called vector brackets. Whenever you see this, see it it's like a pointed bracket. We know that that's not an ordered pair, that's a vector. And the first number is always your horizontal component. I'm going to label that too. So the first number is your horizontal component. We call that the horizontal component, which is my delta x. And the 2 is my vertical component. Okay, so now that we have that, we can find our magnitude and our direction. So this is my vector. And now we're going to find the magnitude and direction of our vector. And to do that, we're going to follow the formulas at the very top. Remember, these formulas that I have highlighted in yellow, you have to know these formulas. They will not be given to you on the test. So in your notes, this might be something you want to circle or put a star next to, because as you're starting to study, or when you start to study, you need to know what's given and what's not going to be given. This is not given, okay? So now we're going to use those two formulas to find the magnitude. I'm going to abbreviate magnitude, MAG. So MAG is going to be the square root of horizontal squared plus vertical squared. So you see how after you find your vertical and horizontal component, we use that to find our magnitude and our direction. So go ahead and figure out what that is. as a decimal. I did not write it.
What is like the unit for it?
There's no unit. Mm-mm. So your calculator could have written it also, simplified it in radical form, or I would also accept it in decimal. So I gotta type it in though, because I didn't write the decimal. 6.325. So on the test, I would accept either one of these answers, honestly, for full credit. That's your magnitude. All right, now let's talk about direction. The direction of our angle. To find direction, we're going to take the inverse tangent of the vertical over the horizontal. So that would be 2/6. Go ahead, type that in your calculator. And I got 18.435 degrees. Okay, so something important to keep in mind is that you do have to check your quadrant. And we'll talk about that in more detail. But this is what I mean by that. Even though this is a vector, on a coordinate plane, what quadrant would that fall in? Where is X and Y both positive? What quadrant? 1. And in quadrant 1, let me just do it down here. So this vector would fall in Q1. So it's going to fall in Q1. And we know that angles in Q1 are between 0 and 90 degrees. Did I get an angle between 0 and 90 degrees in my calculator? Okay, so we can leave it alone. And we'll talk about what to do when that does not work out that way. But essentially, you're just simply going to add either 180 or 360. All right, so now let's get to example 1. We're only going to do the first page today, or page 2 today. So when we look at example 1, okay. Notice that they already gave us component form. And how do I know this is component form? Because of these brackets. Whenever you see these brackets, these are vector brackets, I know that I don't need to find it. This is delta X and this is delta Y. So I'm going to freeze my screen. I want you to find your magnitude and direction, and then we'll see if we agree. Thank you. All right, who has an answer for magnitude and direction? All right, I'll give you a minute to look at what I came up with. Who had that? So let's talk about this component. What quadrant, let's talk about the direction I meant to say. What quadrant is x positive and y negative? 4. Who agrees that's quadrant 4? What are my angles? What do they have to be in between? What's the angle right here? Keep in mind, this is 360 degrees going around. So what would this have to be right here? 260, 270, 360. So did I get a number between that though? So do you think I'm going to add 360? It's either you're going to have to add 180 or 360. Which one am I going to need to add? 360. Go ahead and add 360. Oops. And that would be my direction. That's it. Now for part B, they did not give us the component form. So we don't know our change in X and change in Y. We need to find that. So in order to find that, the initial is always your 0.1 and the terminal is 0.2. So I'm going to label this one X1, Y1, X2, Y2. Let's find our delta X. Delta X is always X2 minus X1. So in this example, it would be 3 minus -2. And delta Y is Y2 minus Y1. It's just 10 minus 6. So what is 3 minus -2? 5. And 10 minus 6? 4. So my component form, because there is a question on the test where it says write it in component form. So I did spend yesterday looking at that test. My component form would be 5, 4. Component form, you simply write the horizontal and vertical components. That's it. So now that you have that, I'm going to freeze my screen. Find the magnitude and direction of that vector using the formula. All right, go ahead and check your answer. Who agrees with what I got? for the second one. All right, I'll give you a minute to look at that and correct your work. Any questions so far? So the reason why I gave you 17 and 18 together is because the questions are kind of jumbled up a little bit. Like, I'm gonna probably change the due date and have them do the same day. But I did cut Emma for number 17, homework 17. I cut 4, 5, and 6. So probably for next year, I'm gonna condense it down, make it one homework or something. I don't know. All right, so now let's finish it out for today. Let's look at example 2. Finishing kind of early. I might do for homework 17. Yeah, I wrote it on the board, but I didn't put it. Yeah, I was just looking at it and I was like, I don't really like this homework so much. Especially now that I have looked at the test. We're gonna do one more question though. This is not, because we got time, so we gotta keep moving a little bit more. We'll do one more. Okay, so now the next formula that you need to know is, what if we have to find the horizontal and vertical component? So here, this notation, when you see this, let me write it down here. This double bracket, this little notation that you see with that half arrow, this means magnitude. That's the symbol for magnitude of vector W. That's what that means. And we already know that that theta, that's your direction. So what we just finished doing was, we just finished trying to find the magnitude and direction, given the horizontal and vertical component. Now we're gonna go backwards. They gave us the magnitude and the direction, and they want us to find the horizontal and vertical component. So second formula, ding, 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 make sure you highlight it in your notes. To find your delta x, which is your horizontal component, it is the magnitude times the cosine of your direction. And your delta y, what do you think that's going to be? Magnitude times what? Sine. That's it. Just make sure you know these are another important formula to know for the test next week. So now we're ready to find it. So to find delta x, you're simply going to take your magnitude, which they told us is 7. So in our direction above, it said the magnitude is 7 and theta, or my direction, is 20. That's given to us in the problem. So we're going to take 7 times the cosine of 20 to find your horizontal component, and then your vertical component is 7 times the sine of 20. And you're going to write it in component form, which simply means we're using our vector brackets.
How much are you rounding?
We're gonna just stick to the thousands place for here on out. So for I'll give you a minute to type those in your calculators. Okay, so I got, for my horizontal component, 6.578. And for my vertical component, 2.394. Anyone else get those numbers? And again, you're gonna put it in that to show that it is a vector. Those are vector brackets. All right, so let's go to page 3 because we got time. We still got 14 minutes. So we'll do, these next ones they go pretty fast, so. Oops, we're not there yet. Okay, so let's look at this one here. So example 1, we have a vector. So these are operations with vectors, and it's pretty simple. We have our first vector, which is vector v. We have our second vector, which is vector w. They want us to multiply -5 by vector w. That's it. And it's no special operation. So if I take -5 and I multiply that by negative, if I take -5 and multiply that by vector w, you simply distribute. So what do you get? That's it. That's your answer. Simple. Now you can do that also using more than one vector. So for question B, we're going to multiply vector w by 4. So vector w, multiply that by 4. And then we're subtracting from that vector v. And we're still going to follow the order of operations. So you're going to first distribute or multiply. Go ahead and do that first. So you should get 12 minus 16. Okay, and now you're going to subtract. So take 12 minus 6. And what do you get when you take 12 minus 6? 6. And then take -16 minus -6. So in your calculator, take -16 minus -6. -10. Try to do that next one by yourself. We'll end off at example 2. That's our last one. But these go pretty fast, so you can just knock them out. That would be my final answer. So looking at example 2, we got 2 new vectors. You're going to take that first one, 3, and multiply that by vector v. And then you're going to take the second one, multiply that by 2, and then add those 2 together. I'm going to freeze my screen and give you a chance to work through it, and then we'll see if we have the same answer. Who has an answer? I don't want to show my screen until you all have an answer, though. Who's still working? Anybody need more time? Nope. Okay. All right. Who got what I got? So I multiplied this one by 3. And that gave me 12 and -3. Then I multiplied w by 2. And I got negative 6 and 10. And then I added these together. All right, do B by yourself. See if we get the same answer, and then we'll end there. You're always following order of operations when you do these. And this time we're using B for both. Multiply it by 2, multiply it by negative 5, or 5. Either multiply it by negative 5 and add, or multiply it by 5 and subtract. So whichever way you prefer, same thing. All right, who has the answer? Okay, see. Who agrees with what I got? 12, negative 12, positive 3. Who got that? Negative 12, positive 3. All right, so for homework 17, you can do the front page of homework 17. The front side, I meant to say. So number 1, you just tell me if it's a scalar or a vector. If you have direction, then it would be a vector. Number 2, you do your operations. And number 3, you find magnitude and direction. And you have to write it in component form. So can we talk about number 3 real quick in the homework? Question 3 in the homework. Can everyone look at homework 17? Number 3. Do you see how it says A, B, and it has an arrow like that? Okay, and it told you that A had a point of 10, negative 2, and then B is 3, negative 5. It doesn't tell you which one is the initial and terminal, but it does at the same time. It told you in this notation that the first letter in the vector was your initial. Okay, so this is your initial. So it's important that you call A x1 and y1 because it came first in vector notation. That's how we know that A is the initial point and B is the terminal point. This is my terminal point. So we're going to call this x2 and y2. So you should be able to finish the front side of the homework.